Hello, everyone. In this lesson, I'm going to go over with you some questions that you will encounter in calculus. And these questions I have selected that you will see in calculus. And of course, at the time, you'll be doing your calculus part. And today we're doing the algebra part. For those of you who wish to review or improve your algebra, please get your paper pencil ready and work with me and follow me until some of you may have to do this over and over until your algebra is much improved and you can do all of these questions independently by yourself. The first question. So the instruction says we just apply this formula, okay? Because we're not doing calculus class, we're doing pre-algebra, pre-calculus. So we're doing the pre-calculus stuff. So we're going to apply this formula to the function f of x equals x squared and a equals to -5. And how does it work? Okay, so we're going to follow the formula. So first we're going to get f of a and f of a plus h. Okay, so we're going to write f of a plus h, f of a. Since a is -5, we're going to replace a by -5. So this will be -5. And so in our situation, our current situation, when we apply the formula to this particular example, a would be -5, -5. Okay? And then how do we get f of -5 and f of -5 plus h? So we're going to plug in the function. And here's the function, okay? We're going to bring the function next to us. So when f of x equals x squared, that's the rule of the function. So when x equals -5, the x on the other side, x will be replaced by -5. -5 squared. -5 squared is -5 times -5, which equals to +25. Be aware that -5 squared with parentheses about -5 is different from without the parentheses. Okay, so these two is different. Okay, different from the other one. What's the difference? What is the difference? We know that -5 squared with parentheses about -5 is +25, but -5 squared without the parentheses about -5 is equals to -5 times 5 equals to -25. Okay, so this is just a little side trip to review algebra. And next step, we're going to have -5 plus h replace x squared. Okay, so this time -5 plus h will replace x. Okay, so to work it out, you can either FOIL. Okay, you can either FOIL. If you FOIL, you would do the -5 plus h. But you can also, which I encourage you guys to apply the formula a plus b squared, which is equals to a squared plus 2ab plus b squared. So we're going to apply this formula. Okay, so let's keep going. We apply this formula. Obviously, a is -5, b is h, right? So a negative 5 squared plus 2ab, 2 negative 5 times h plus h squared, okay, equals to, we got 25 minus 10h plus h squared. All right. And now we got f of negative 5, f of negative 5 plus h divided by h, right? We can do this gradually. So next, we're going to compose the numerator. So that's the negative 5 plus h minus f of negative 5. We get to plug in, right? F of negative 5 plus h is 25 minus 10h plus h squared. So we take all of these, and f of negative 5 is 25. So subtract 25. And then we're going to combine like terms, right? So 25 minus 25, that makes 0. So we will be left with negative 10h plus h squared. And after that, usually we would like to factor it. We're going to factor the h out. We get a negative 10 plus h. So by now, we have finished the numerator. And now we're going to do the whole of the expression required. We're going to plug in. The numerator is found. H multiply negative 10 plus h divided by h. And you can see it's rather useful that we factored it. So h and h will be reduced. So in the end, the answer would be negative 10 plus h. And that is finished. So we've done the algebra part. Once you're getting better at this in calculus class, you just have to do one more or maybe two more steps. You'll finish the question in the calculus setting. Okay, so that was the first question. Number 2. Okay, number 2. Number 2, we have the question here. Okay, we have the question right here. The function in our consideration is, I'm going to bring the formula with us. Okay, I'm going to bring the formula with us so we can use it, with convenience, so I don't have to type repetitively. Okay, so in this case, we're going to do the same thing, but this time a is 3. So this is going to be 3 plus h, f of 3. And the function is f of x equals x raised to the power negative 1. Okay, so once again, we're going to do f of 3, right? And then we're going to do f of 3 plus h. F of 3 is going to be 3 to the power of negative 1. F of 3 plus h is going to be 3 plus h to the power of negative 1. Okay, and it looks like we cannot reduce further, but be aware 3 to the power of negative 1 is really just 1/3. Okay, 3 plus h to the power negative 1 is really 1/3 plus h. How do we know that? Well, in our algebra class, we have learned that b raised to the power of negative n is equals to 1/b to the power of m. N can be, any number. Okay, N can be any number. All right, so that's something we're going to make association with. And next, we're going to compose f of 3 plus h minus f of 3 divided by h. Okay, so now we got the numerator, right? F of 3 plus h, that's 3 plus h to the power negative 1 minus 3 to the power negative 1 and divided by h. Now you say, oh, how do we reduce that? Yes, we can, right? But most of us probably is more familiar with the latter form, which is divided by h, and the right, 3 plus h raised to the power negative 1 in the fraction form. Okay, if you want to do that, perfect, no problem. I believe that's probably most of us. Okay, so this is a complex fraction. Okay, in algebra, we done complex fraction, right? So we're going to use a complex fraction technique to reduce this expression. Okay, to reduce this expression. And what is that technique? That technique is to first find out the common denominator, okay, the so-called LCD. Okay, but what is the LCD? When we have one fraction, two fraction, well, you can see this as a fraction. Well, the denominator, you can see it as a fraction, which is h over 1, right? So the really significant denominator will be just 3 plus h and 3. So we can just work with the two denominators. The two denominators is 3 times 3 plus h. So the LCD is 3 times 3 plus h. And we make number 1. Why we make number 1? Because anything times 1 stay the same. Mathematical principle, right? So we make a number 1. So this is a 1. Anything times 1 stay the same. Okay, be careful. You must write this twice. Okay? Then you say, well, if I don't write it twice, I'm just write it once, right? I'm writing h times 3 plus h. That would be wrong because this quantity is not going to, well, may or may not be 1. If this is not a 1, you multiply some number that's not equals 1, so these two are no longer equal. So you must write that twice. Okay? Honor our mathematical principle because so anything times 1 stay the same. Anything times 1 stay the same. Then what do we do with? What do we do with it? Okay, this is what we do with it. Okay, we're going to take the numerator. The numerator is going to multiply numerator, okay? In this whole setting, when you write it down, you make sure you have the proper lining up. So for example, the equal sign should be on the same level with this thicker fraction bar. Okay, there's other two fraction bars, but you can see their color is lighter. So the equal sign should be lining up with this major fraction bar. Okay, so we take the numerator to multiply with the numerator, and we take the denominator to multiply with the denominator, okay? So we can combine these terms. So this piece is going to be distributed to the first term, to the second term, remove that parentheses, and the bottom, you can write 3h if you want. Okay, h times 3, 3 times h, same thing. With that, you can see we can reduce this piece, right? 3 plus h and 3 plus h, that will be reduced. We have a 3 left. And 3 times 1/3, that equals to 1. If it's 1, we can omit it. And next, we are going to open up the parentheses. We're going to get a -3 minus h. Okay, it would have been a mistake if you keep the plus h. Okay, so by now, 3 minus 3 is 0. Okay. And this h and the h in the denominator will be reduced. So near the end, what do we get? H, reduce the h in the denominator, and that question is finished. That question is finished. Do you need to multiply 3 with 3 and 3 times h? No, not necessary. Not necessary. So you can just leave it like that. Okay, so this second question is also finished. Okay. Let's look at the third one. Let's look at the third one. Oops. We don't want this one. Okay. Let's look at the third one. The third one, we have this expression to work with. Okay. And a is 2, so this is a 2 plus h, 2, f of 2. And so we're going to plug in, right? So let's see what we get. F of 2, right? F of 2 f of 2 is going to be 2 to the power of 3. 2 to the power of 3 is 2 times 2 times 2, 3 times. That equals to 8. And how about f of 2 plus h? Well, that's going to be 2 plus h to the power of 3. Okay? And then we're going to FOIL this. We're going to FOIL this. Let's see what we get for foiling. Okay? You can directly FOIL, or if you know the formula, that's okay. In any case, I'm sure you can handle this, but it does look a little bit, sometimes we may not be in the mood to do it, but let's do it, okay? So if you don't remember the formula, if you remember the formula, you can use the formula, okay? You can use the formula, but if you don't remember the formula, it's really not a big deal, so you can just do this. 2 plus h squared multiply 2 plus h. Okay, so what do we get here? We know how to do 2 plus h, right? That's a squared plus 2ab plus b squared. So we're going to get a 4 plus 4h. Okay, plus h squared. Okay, and then we're going to multiply 2 plus h. And now what we got is that we're going to 2 times 8, 2 times 4 equals to 8, times 4h equals to 8h plus 2h squared. Okay, and next round we're going to take the h, multiply each one in the front parentheses. So we're going to have 4h, you can write it this way, 4h plus, okay, let me make that proper fonts, So 4 times h, then 4h squared. 4 times h squared and plus h to the power 3. H to the power of 3. And then last but not least, to complete this FOIL, we got 8, we got 12h, we got 6h squared plus h raised to the power of 3. You can see with patience, we got everything, right? With patience, we got everything. So next, okay, next, we're going to do this numerator. We're going to do the numerator. The numerator is f of 2 plus h minus f of h. We know f of 2 plus h is this piece, right? So we're going to subtract f of 2, which is 8. The negative 8 and positive 8 will make 0. So we will get just these 3 terms. And thinking of a factoring, right? Thinking of factoring, so you factored out the h. And this will factor out the h, and this will be after factor out the h. Okay, so let's quickly double check. Okay, it's always safer to double check. Double check our work. Okay, so a squared plus 2ab 4h plus h squared, and 8h, 2h squared, 4h squared, and h raised to the power of 3. I don't see any problem. Okay, let's move forward. So now we're going to compose the whole of it. We're going to compose the whole of it. And that should equal to, the denominator stays to be the h. The numerator would be that factor form. Can we factor further? Do we need to factor further? Not really, right? Because in this case, it might not be that easy, but we'll factor out the 1h. That's good enough. So we got h and h reduced. In the end, we got 12 plus 6h plus h squared. And the question, the algebra part for calculus now is finished. Okay, so before we move on to number 4, you can see in these 3 examples we did, right? We did polynomial case, the simplest polynomial case. We did reciprocal function, and we also did, x raised to the power 3. You're going to see more varieties of functions. You're going to see more varieties of functions. But if you want to improve your algebra and getting ready for calculus, and you are indeed doing the algebra in calculus, that I assure you. Okay, number 4. Number 4, you can see in terms of complexity, it has increased. Okay, so we are going to bring the formula with us. Okay, we're going to bring the formula with us. But in this case, a is 3. So a will be replaced by 3. And then we're going to work out, once again, something simpler, just to get it done, So f of 3, so what is f of 3, right? So f of 3, we're going to plug in, right? This is f of x. So now, if f of x is such f of 3, then x replaced by 3, then every x will be replaced by 3. Okay, and then you evaluate. You get negative 15 plus 1, and this is going to be 2 times 9, right? So soon enough, you get the number. That's 4. Okay, arithmetic. F of a plus 3, I'm sorry, f of 3 plus h. This part gets more interesting because we have a little more complex situation. X will be replaced by 3 plus h. Okay, so we see some work to be done. We see some work to be done, right? So at 2 times, this is the moment in order to improve our algebra, we have to be patient with ourselves, okay? So 3 plus h squared, we got a 9, 3 squared, right? Plus 2ab, that's a 6h plus h squared. Oh, h squared minus, okay, we're gonna negative 5 times 3, that's gonna be negative 15. Negative 5 times h, that's minus 5h, and plus a 1. Okay, and moving forward, we're going to distribute 2 inside every term inside the parentheses. So we're going to get 18 plus 12h plus 2h squared. Okay, combining like terms now. So let's combine like terms. What do we get? Negative 15, positive 18, right? That makes 3. 3 plus 1 is 4. So these numbers are combined into a 4. 12h minus 5h, that makes 7h. Okay, so that's what we got. You can rearrange it, certainly, no problem, okay? But keeping this way is fine. Keeping it this way is fine. And then we're going to compose the numerator. Composing the numerator, so f of 3 plus h is this piece. Subtracting f of 3, which equals to 4, and 4 minus 4 makes 0. So we ended up with 7h plus 2h squared. Factor out the h. You can see factoring is a common theme, right? We have 7 plus 2 times h. Almost there, almost there. So then we're going to divide by h. So near the end, the numerator we found, denominator is an h. H and h reduced, so we get 7 plus 2h. So this question is finished. This question is finished. All right, continue. Now, another polynomial. Okay, so be patient with me. We look at number 5. We have other types. Okay, as you can see. So let's go. And that's the form we're going to work with. Of course, a equals to 1. So a equals to 1, replacing a. And then we'll be working with f of 1. Right? It's totally manageable. You can totally do it. Okay, so that equals to 0. F of 1 equals 0, but what is f of 1 plus h? F of 1 plus h, right? Because x equals to 1 plus h. 1 plus h will be in the place of x. Okay? And this time we're going to FOIL. Okay, so this is really basic algebra, guys, and this is the best opportunity for you to review your algebra and enhance your algebra to get yourself ready for calculus. Okay, because most likely you're going to have to do this in calculus time, over again. So this piece is going to be 1 plus 2h plus h squared. Okay, and the other part, right, if we don't remember the formula, then you just FOIL. You just FOIL, okay? You can do 1 plus h to the power 2 multiply 1 plus h. Just a second. As I'm doing this, I suddenly realized maybe we can simplify this process, right? Okay, so let's try this, okay, guys? You can still do the FOIL, but now I suddenly realized we can make it a little easier for ourselves. You see the way we write it, right? It's 1 plus h squared minus 1 plus h squared times 1 plus h. So I'm going to factor out this piece because we have that in either form. So this will make it, after this one is factored out, this is factored out. What's left in the bracket is 1 minus 1 plus h. This actually will greatly reduce the amount of work we have to do. Let's see how. 1 minus 1, so we open the parentheses. So we have a minus h here. So the bracket will be left with minus h, right? And then what? Then we're gonna plug in here. We're gonna plug in here, okay? When we plug in here, f of 1 plus h is equal to this piece. F of 1 is 0, right? And h. And reduce it. You see, our life is a little bit simpler had we just have a little change of strategy, which is factoring. So minus 0, we can omit that. There's a h is reduced, right? So in the end, we just get a negative 1 plus h squared. And if you like to write it in its FOIL form, no problem. But if you keep it as is, it is fine. So this question is considered finished. To consider finished. Okay. Then number 6. This time we are working with a fraction form. A is 2. Okay, let's continue. As you can see that this function is a bit more interesting, right? It's not a polynomial, it is a rational function. And you may ask me, are we going to meet this kind of function in Cal? I can assure you, yes, for sure. Okay, you may meet this question exactly. Okay, let's see f of 2. What is f of 2? F of 2 will be this function replacing x by 2, right? So 2, 2. Okay, we don't need that anymore. What is this? Excuse me. So 2 plus 2 is 4. 2 minus 3 is negative 1. So we get a negative 4. What is f of 2 plus h? f of 2 plus h. Then we're going to bring this function. Every x will be replaced by 2 plus h. 2 plus h, 2 plus h. Okay? And then what do we get? We cannot reduce the 2, guys. Okay, so we're going to reduce it. We're going to simplify it. 2 plus h plus 2, that's h plus 4. The bottom, 2 plus h minus 3, that's h minus 1. Okay, so now we got f of 2 plus h. How about f of 2 plus h minus f of 2? Well, we have this fraction form subtracting negative 4. Okay, minus negative 4, that's a plus 4, right? So we got this piece, and now it's a plus 4. And then what do we do? Can we reduce further? We can, we certainly can. We can make a common denominator here. We can make a common denominator here, or we wait until the next step, okay? Because we will have another similar question. So this time I'm going to make the common denominator here. Okay, so common denominator, algebraic skill. So we get to practice that. So we're gonna make common denominator, so we're gonna multiply h minus 1 over h minus 1. So now we have the same denominator. We bring the 4 on the top, right? So 4 times, right? So now we have the same denominator. And then we will keep the same denominator and add the numerator. Okay, so h plus 4 will be added to the next numerator. So this part is gone. And then we're going to combine the like terms. Okay, to see what we get. We get h minus 1 in the bottom. Opened up this parenthesis, that's the 4h minus 4. Okay, 4 times h, 4 times negative 4. Combining the h's, and positive 4, negative 4 makes 0, right? So we get a 5h. So now we're ready to compose the whole of it. And numerator, which is finished. So the numerator is going to be placed in the place for it. And how do we reduce this? Well, this is what we can do. Okay, be careful that this is a fraction bar. This is a dark one. This is another fraction bar, but this dark one should be lining up. This is the very center, right? The numerator, here we have a numerator, we have another fraction which denominator equals to 1. So one thing you can do is you multiply h minus 1 on top, and you also multiply h minus 1 in the denominator. So that way, this guy will multiply with this guy, so the denominator will be rid of. Okay, so you're gonna have, you're gonna do this. Okay, so this is h minus 1. You must have the parentheses. And this piece is h minus 1. I'm sure some of you might be better at this, and you can go forward. Okay, you can move forward. You don't have to wait for me. And oops, reducing. Okay, so this h minus 1, take away this h minus 1. So the top is just 5 times h. And then what? H and h will be reduced. So we will have 5 over h minus 1. Finished. Finished. Okay, so this is number 6. This is number 6. Let's look at number 7. We're getting some radicals. Okay, we're getting some radicals. Great. So we have even more opportunity to practice our algebra. Okay. Number 7. Okay. We have f of x and a equals to 1, right? So we're going to be doing that, right? A equals to 1, so it's 1 plus h, f of 1 equals to, we're going to do f of 1. What is f of 1? F of 1 is the square root of 1, right? Because that's when x is equals to 1, it equals to 1. What is f of 1 plus h? F of 1 plus h is equals to root 1 plus h. Okay. And then we're gonna do the numerator. And what we got here is going to be f of 1 plus h minus 1. Can we wait? The root 1 plus h minus 1. Okay? Not much we can do. We're going to go straight to the next step. Now we got denominator still h, numerator is that piece. How do we reduce it? How do we simplify it? Is there a way? Yes, the answer is there is a way. The way is the conjugates. Conjugates. Okay, so we're going to rationalize the numerator. So this turns into plus 1. And numerator, denominator the same. So anything times 1. So we just multiply by 1, right? 1 is replaced by this desirable expression that will help us reduce. Equal, the denominator would be h multiply that. Oops, sorry. This guy. My bad, sorry. And the top is a product of conjugates, right? So it equals to root 1 plus h squared minus 1 squared. 1 squared is 1, right? So we got it. And then what? This piece is just a 1 plus h, right? It's just 1 plus h. And 1 and 1 reduce, make 0. So when h on the top and h in the bottom were reduced, right? So on the next step, -1 and +1 makes 0, and h will be reduced. So that's it. Simplified. Radicals. So we have seen so far variety of types, right? Different types. Polynomial, roots, rational. Okay? So let's look at another radical. Let's look at another radical. Okay? So the function would be something like this. Okay, something like this. This looks a little more complex, right? But no fear, okay? I'm here helping you, so please follow me. If you need to take a break, go ahead, take a break and come back. And make sure you pause the lesson. All right, so we're going to do, wait, okay, I'm getting this piece. I'm gonna bring that piece with us. Okay, I'm gonna save a copy for the next question. So now, A is -1, so A is -1. A is -1. So first we're gonna do, you know, f of x. When x is -1, so 3 multiply x, x will be replaced by -1. One is -1 plus h, -1 plus h, -1 plus h will be in the place of x. Okay, substitution. And we got two radicals here. So 1 minus 3 times -1, that's 1 plus 3. So it's a root 4. Root 4 is a positive 2. And next, okay, so here, there are a couple of things we can do, okay? I think I recommend you to do a little bit something, okay? So what you can do is you take the -3 distributed to inside the parentheses. Okay, so I'm going to get +3. I'm going to get +3 minus 3 times h. Okay, because -3 times -1, that's a +3. -3 times h is -3h. And 1 plus 3 is a 4. Okay, so next we're going to do the numerator. The numerator is going to be the one subtract the other. And there's not much we can do there, so we're going to do the whole of the expression. Okay, so finally we got divided by h. Now the top is that form. Well, we know the common technique to do this, which is by rationalizing the numerator, right? We're gonna find the conjugate of the numerator. This piece is becoming +2, okay? And then moving forward, the denominator would take the h to multiply the other denominator, and numerator times numerator. Numerator times numerator, we have a conjugate a minus b, a plus b, right? So in the end, we get a squared minus b squared. I hope everybody follows me. Okay, that's the numerator times the numerator. And then keep going. And this will be equals to 4 minus 3h. And 2 squared is a 4. So 4 and 4 make 0. So our next step is going to be the 4's are gone. H and H will reduce. So in the end, if you can do all of these algebra fluently, you will have a much better time in calculus. Okay, because you'll be so ready, so you're just ready to absorb the theories in calculus. Okay, enjoy the process. All right, so that was done, number 8. Number 9. Okay, number 9, we're back to this rational function once again. A is 1. We're gonna go ahead with f of 1 plus h. You know, this is the perfect opportunity for you to practice your algebra, to review your algebra. And so this is 1 plus h. Okay, so when x equals to 1, x will be replaced by 1. What do we get? 2 times 1 is 1. 2 times 1 is 2. 2 plus 1 is 3. And the numerator is 3, denominator is 3, so we got 1. 1 plus h. Every x replaced by a 1 plus h. Okay? Don't panic. We can take care of this, okay? I know this may look more more complex than the algebra you saw when you took it years ago. Okay, I know there might be some hardship for you, but keep on practicing. First time, just to make yourself comfortable and just follow me. Okay. I'm just going to get you there. Okay, so 1 plus h plus 2, that makes h plus 3. And the top, we're gonna have 2 plus 2h plus 1. So we're gonna have 2h plus 3. Yay. Okay, so it looks a little simpler, but this time I'm gonna use a slightly different way to do it. Okay, so I'm not gonna find the, I'm not gonna do the numerator alone. I'm gonna do the whole thing together. So numerator, okay, be careful about the lining up, right? The major fraction bar and the other fraction bar. So this, oh sorry, so this is the fraction, a minus, oh wait, this is a 1, I'm sorry, this is a 1, 3 over 3 is a 1. Why did I do that? So this is a 1. Okay. How do we simplify this complex fraction? Of course, we multiply by 1. And this is going to be common denominator, which is h plus 3 on both top and bottom. So at the same time, right, you can just multiply this piece with that and with that, and multiply this piece with the denominator. So numerator times numerator, denominator times denominator. And simplify, right? So h plus 3 will reduce with h plus 3. And this piece will just be 2h plus 3. 2h plus 3. And the second part, this is a -1, we can omit it. We can subtract the inside. So we get a -3. And now with all of that operation, -h, 2h, so that combined into just 1h. 3 and 3 makes 0. H and h reduced, so we ended up with 1 over h plus 3. So you saw that process, right? You saw that process. You got it. And we're done. We are finished, right? So in the process, we have learned how to reduce complex fraction. So 2 more to go. I think we can make it into our time, okay? Number 10 and 11. Okay, number 10. So I'm going to put this for number 10 and put this for number 11. And we shall finish. We shall finish. Okay, so we see a variety of types. Polynomial rational roots, right? Number 10, we have 6 is for A. 6 is the value for A. So we're gonna work with our functions. So when x equals to 6, every x replaced by 6. And that's root 24 plus 1, 24 plus 1, that's a 25. Root 25 is a positive 5. 6 plus h in place of x, right? So every x will be replaced by 6 plus h. So that's substitution. Let's do a little reduction, right? So we opened up the parentheses, so we get a 24 plus 4h. Okay, and 24 plus 1, that's equals to 25. So we got that. And then we're going to go straight to our expression. And numerator, denominator is h. Numerator, we have 1 subtract the other. Okay, we have 1 subtract the other. Be patient with ourselves. We can do it, and we've done so much, right? And you are improving your algebra along the way. And it is also most comforting is that you know these are the algebras you will be doing in calculus class. So at the same time, you're reviewing your algebra, enhancing your algebra, you're getting ready for calculus. All right, so rationalization. This is root minus 5. So this root plus 5 is the conjugate. So we have this conjugate over conjugate, same numerator, denominator, so we multiply by 1. So this 1 is going to be made up this way, right, as we know. Okay. Equals to denominator multiply denominator. So denominator is going to multiply the denominator. You need that parentheses. Don't drop the parentheses, right? Numerator times numerator. That's a conjugate pair. So that we're going to get squared. So this is a squared minus, wait, I'm sorry. This is 4h plus 25. Okay, this is the a squared minus b squared. All right, b squared. And then equals to, and the first square is just going to be 4h plus 25. And 5 squared is 25, right? Reduce it. 25 minus 25, that's 0. H and H reduced. So in the end, H is gone from reducing. The parentheses is no longer needed. And this is the end for this number 10. Okay. Last but not least. Okay, you can see the whole process. We're just repeating the same, repetitively using the same formula for different functions for different a's. Okay. And last one, a equals to -1 this time. So -1. So let's plug in f of x. F of x, a equals to -1, right? We're working on f of -1. So this is -1. So x will be replaced by -1. Don't forget this parentheses, okay? -1 to the power 4 is 1. Multiply 5, that's a 5. -1 plus h. Okay, so x will be replaced by -1 plus h. So the other x on the right-hand side will be replaced by -1 plus h. All right. Oh, then you say, oh my God, we're going to have to FOIL this. Well, there's no rush. There's no rush. We might have some, some interesting situation coming up. Okay, so no fear, don't be afraid. We're not going to FOIL that 4 power, not yet. Okay, and we may not need to. We may not need to. Okay, so keep going. Follow me. Okay, but if you want to pause and FOIL the whole thing yourself, go for it. You can pause that and then come back and to see what I would do. Okay, so I'm not going to FOIL that. Okay, so this one -5. Now the question is how we're going to reduce this. How we're going to reduce it. This is once again opportunity to improve our algebra. Okay, so this piece has a 5, this piece has a 5, so I'm going to factor out the 5. Okay, so 5 is being factored out. So I got this -1 plus h to the power 4 minus 1. And then I'm going to do the following. I'm going to make this power as 2, and 1 squared. I see 1 as 1 squared. So I got a squared, okay? I got a squared minus b squared. Okay? A squared, recall that formula, right? That formula is very useful, especially for academic questions. It's not only useful for rationalization, it's also useful for some other situations such as this one, All right, so I see this as a squared, right? This is a, what's in the bracket is a minus b squared. So I'm going to use a factor. So our next step is going to be the factor form, right? So it's going to be a minus b, right? So it's a minus b multiply a plus b. Okay, so it's just because this is a conjugate pair. A minus b to a plus b. Okay? Now you can see we kind of averted the necessity to FOIL the fourth power, right? But we still need to reduce it, right? And so by this time, I'm going to work in each bracket. But in each bracket, the work will be a little less intensive, right? -1 plus h squared, so that's just going to be equals to 1 minus 2h plus h squared. Much less work. On this piece, okay, it's going to be the same thing. It's -1, it's 1 minus 2h plus h squared, same thing, right? Because they're both -1 plus h squared, right? And be patient. This is really the perfect opportunity for you to review all the algebra you've done before and getting ready for calculus. I cannot repeat that more. All right, so on the second bracket, you basically get 1 plus 1, that's going to be 2. On the first one, it's 1 minus 1, so you get a 0. On the first bracket, you can factor out the 8. Okay, so let me write one more step. So I'm going to factor out the h. So this will be -2 plus h. And what happened with h? H and h will be reduced. As you can see on all of these questions, actually, our final goal is to reduce to the point that H will be reduced. Okay, so we finally got there. We finally got there. So finishing this, H and H reduced, right? So this is 1. So in the end, we just have all of these brackets. 5 times all of that in the bracket. 2 plus H. 2 plus H. I'm going to put it in parentheses, okay? And this piece I can put it in parentheses. It's not necessary. You can keep the bracket, but this looks a little simpler. And then I wish to tell you we are done. We are done. You can actually stop here. Then you say, well, do we need to multiply this out to FOIL this? I say, well, if you want to, you can, but you don't have to. You can just leave it like that. Isn't that nice? Isn't that nice? I think so, because oftentimes in calculus, I just want you to remember one rule of thumb. There's a rule of thumb, so there are exceptions, but in most of the cases, I mentioned this before, I believe, in other videos, that if you can keep a factor form, if you can keep a factor form, just keep it a factor form. Until maybe sometimes you need to expand it or foil it. But in this case, you don't need to. So we are finished, reduced. So all of these questions, as you can see, right? This is actually the algebra in your calculus, is so that in the form that we are working with, right? Let's look back what we've done. So for all of these, all 11 questions, what have we done is that to factor numerator such that it will cancel out the H in the denominator, or reduce the H. So that's the common goal. And in calculus, you're going to do that one time over, okay, or more times over. Okay, so that's all for this lesson. Thank you for watching.